Bonnie, are we ready to go?
All yours.
Great. Well, a big welcome to everyone who's joining us today. I won't say good morning or good afternoon because I'm noting that people are calling in from a range of different time zones today, but I will say hello. Before I go any further, I want to acknowledge the traditional owners of the lands that we are all based on today. I'm here at the Australian National Maritime Museum in Pyrmont, and one thing we like to do is to acknowledge not only the traditional owners of the land, but the custodians of the waters on which we all live by and rely on so much for our lives. My name is Peter Tattersall. I'm the head of learning here at the National Maritime Museum, and I'm incredibly happy today to be connecting all of you with the wonderful work that the Schmidt Ocean Institute are doing in the area of ocean science that we're all about to hear a lot more from, and the RV Falkor based somewhere in the Coral Sea at the moment. Now, I know you haven't called in to hear me talk, so I will pass over now to Carly, who's the Director of Communications and Engagement Strategy at the Schmidt Ocean Institute over in Hawaii. Carly, how are you?
Thank you so much, Peter. We are so excited to be partnering with the museum for this connection today, and happy National Science Week to all. I'm really excited to introduce some of our scientists aboard research vessel Falkor that has been doing some incredible work and some amazing deep sea dives. So at any point, if you'd like to follow the dives that we've been doing, we had one earlier today, you can always follow us at Schmidt Ocean, either on our YouTube, Facebook, as well as our Twitter and Instagram pages. So without further ado, I would like to introduce our scientists, our guests of honor. We have with us today Dr. Robin Beeman, who is a marine geologist from James Cook University, and Marty McNeil, a PhD candidate at the School of Earth and Environmental Science at Queensland's University of Technology. Both are incredible scientists and no stranger to Falkor, who have been doing a lot of work. What exciting dives we've had over the last few days. Thank you for joining us.
Hi, Carly, and hi to everyone at home on shore. It's really wonderful to be able to join you today. We have had some really exciting and wonderful dives so far. It's kept us really, really busy. We're on our toes, that's for sure.
I don't doubt it for a second. Rob, what's been the most exciting moment for you in the last 24 hours?
Yeah, that's right. They just keep coming, Carly. So hello, everybody ashore. So this is Dr. Robin Beeman from James Cook University, and we're sitting in the library of the RV Falkor. You can see the Falkor on the screen there. And in fact, we're just off Ribbon Reef 5, which is in the northern Great Barrier Reef. And this imagery was taken by Dean Miller, our onboard communication specialist, with his drone, and we are still in this same position. So we've just completed a dive this morning, and the ROV only came on board literally about 10 minutes ago, but every dive has its own highlights, and I think we've gotten used to the idea that, you know, we kind of look at each other and reflect and go, what was the highlight for you? There's usually a geology highlight and a biology highlight, but on this one that we just brought up, we saw a Dumbo octopus, really amazing looking octopus, and we saw another deep sea octopus. Marty, what was your highlight?
Well, I was going to say the octopus as well. So that was probably the biological highlight on the dive that we've just done. Thinking back to yesterday's dive, so apart from the geological highlights, so Rob's a marine geologist, I'm a reef carbonate sedimentologist, so we're interested in the rocks and sediments, and we've seen some really cool stuff here. But I think the highlight for me yesterday was the pygmy seahorse on the Gorgonian soft coral. I've heard you talk about them. I've heard other people talk about them, but I had not ever seen one myself. So yeah, that was my highlight yesterday, was that tiny, tiny little pygmy seahorse, like 1 centimetre or 2 centimetres, wrapped around the branches of this Gorgonian coral, which was bright orange, and the pygmy seahorse was orange. It was so well camouflaged. But the amazing skill and experience and techniques of the ROV pilots, they spotted it, and they could zoom right in there, and we got this amazing full screen view of this tiny little pygmy seahorse. So that was my highlight from the last 24 hours.
Yeah, geologically, there's lots of highlights too. So the dive that we've just completed was down to around 1.4 kilometres deep. So around just over one kilometre, to over 1,000 metres. And what we found was the rock that underlies the Great Barrier Reef. So the Great Barrier Reef is approximately, let's say, about 500 to 600,000 years old, but it's sitting on a much older rock basement, and this is in fact the extension of the Australian continental shelf. And it's we now know that it's a hard mudstone. It's probably 40, 50 million years old, and this morning we actually sampled a piece of it, so we could actually see it jutting out from the mud that overlies the continental slope in front of the Great Barrier Reef. And if I think about yesterday's dive, which was a little bit higher up the top of this canyon, we're actually looking at the ancient Great Barrier Reef that grows, sits upon it, and we actually flew up this steep vertical wall about 200 meters high, layer upon layer of ancient coral reef, until you get to the shallowmost top, which is, you know, the parts that we can see in satellite imagery and can swim and scuba dive on. But yesterday we actually passed up that face, and of course there's lots of marine life on it, and Marty just described this pygmy seahorse growing on a huge Gorgonian fan coral that was attached to this ancient coral reef system.
So let me ask you guys, I mean, there's some incredible things happening. You're picking up pieces of history. You're looking at species that maybe have not been looked at before. What does this all mean for you? So what is really the goal of exploring these areas and finding these samples, and what does that mean for your science?
Well, yes, there's an aspect of just discovery science where you just put a camera down and just see what comes into view, and certainly lots and lots of marine surprises. We mentioned the octopus and pygmy seahorses, but in fact this expedition is very, very well planned. We've been thinking about this for well over 6 months, but if we actually think about all the work that's preceded us, we are trying to understand, I guess, several things. We want to understand the deep Great Barrier Reef, which is this ancient eroded margin, and there's an inset view here, and we can see a 3D picture of the seafloor that has been mapped by the Falkor over the past week. And this is a really big view. So this is like a computer 3D view of the seafloor. The Great Barrier Reef itself, the coral reefs, are on this big flat continental shelf sitting at the top. But you know, this is like these undersea valleys, and these are called submarine canyons, submarine being underwater. And the vertical height there is about 2 kilometers. So from the edge of the Great Barrier Reef down into the basin, the whole slope, continental slope of this margin is just cut with these very, very deep canyons. Now, we've been mapping these for many years. The Falkor has been mapping here in the last week, so we're getting really fine detail about what that seafloor looks like. But what we want to understand is how these things form, how these canyons form, what the rock is that they're made up of, the processes that are creating all of this erosion, and ultimately the marine life that lives in it. So we come out here with a bit of an understanding of what the shape of the seafloor looks like. We map it in more detail, and we're always trying to understand how it formed. What does it tell us about the ancient landscape of Australia, and ultimately, you know, how it affects the shape of the Great Barrier Reef as it is at the moment, because it is connected between land and sea, and we have animals and water and, you know, sediments that move backwards and forwards across this interface between the shallow reef systems and the deeper basins. And so we want to understand that, because it does influence ultimately the health of the Great Barrier Reef itself. So we've come out here to do a big sampling exercise to map, to look closely and to ground truth. And by ground truth, I mean we've put a camera down on the seafloor to actually look at these rocks, to take a sample, to actually take marine life back to museums and look at the species that make up this environment.
I was just going to add in there just one or two words about hypothesis testing. So as scientists, and really science is a process, and we talk about testing a hypothesis. So Rob and the other chief scientists and all the other collaborators that are working with us on this expedition have looked at previous work from the area and all the scientific literature that's been written about this area and the work that they've done themselves, and have come up with these ideas, and that's what we call a hypothesis. So we've come out here to test these hypotheses and find out whether our educated guess, our ideas, our thoughts about what we thought the processes might be and what we thought we might find here, whether that's right or wrong, or we need to adjust our ideas and come up with something new, or whether it's confirmed what we thought the processes might be. So that's kind of, from a scientific perspective, that's sort of how we go about undertaking these surveys in a methodical sort of a way.
That's really helpful.
Yeah.
I want to take a pause for a quick second there, and I want to let all of our viewers know that if they have questions as we're going through some of this material, to pop it into the Q&A, type it in, and we'll try to address it before the end of our talk today. Sorry, I didn't mean to interrupt you, Rob. You were about to add on to what Marty was saying.
No, that's fine there, Carly. Yes, and we welcome questions. In fact, we've been live streaming all of these ROV videos on YouTube and Facebook. And what's been really fun is we're sitting in the control room along with the pilots, and we can hear everything that's happening on the ship around us. But we're also looking at all the chat feeds that are coming through on YouTube and the like, and we get direct questions from there, and it helps us to, I guess, guide some of the answers as we speak to what we're seeing in the vision. And so it's very much a two-way process. We're learning because there's certainly lots of experts ashore who know more about, like, the fish species, for example, that we're seeing than so we don't have any fish ichthyologists on board, but we do, in fact, because we have this virtual army of fish biologists who can say, oh, you've just seen a such and such, and you know, we are learning as much from the people ashore as they are from us here on board. So it's very, very satisfying. We're all learning huge amounts, and as Marty talked about, the scientific method. It's really fun to be with a group of scientists who have lots of broad experience, and we all bring our different perspectives, and, you know, we consider each other's ideas, and, you know, and as Marty said, sometimes the ideas that we go down on the seafloor with, what we might expect to see, we don't see it. We have to change our view, and this is the scientific method.
Rob, that's really amazing to hear. And, you know, something that both you and Marty touched on that I think is really important is talking about the different roles. There's geologists and biologists, and it's kind of interesting to see all these different types of scientists come together. Can you speak a little bit more about how you all work together to accomplish your science goals, and what other kinds of scientists are on board?
Yeah, absolutely. So the types of scientists that we've got on board, we've got a number of geologists. This expedition is actually headed up by Geoscience Australia. And so kind of underneath the broad category of geologists, we've got marine geologists, so geologists that specialise in rocks and sediments from marine environments, and that includes the mapping and what have you that Rob does as well. We've got biologists on board. We've got some PhD students from the Coral Centre of Excellence at James Cook University in Townsville. And they are, I guess, more shallow coral reef biologists and ecologists. So they're bringing their expertise as well. And it's wonderful to have them on board, especially with the live streaming of the commentary. We have Jeremy Horowitz, who is a black coral specialist in taxonomy, and he has a broad understanding of the marine biology as well. So that's a real bonus. And so on these dives that we've been doing, we've got this interplay between all of these different objectives, and we've got scientists onshore who are not on the ship that we're also collaborating with as well, and they are joining us remotely during some of the dives as well. We've got Dougal Lindsay, who's in Japan, and he's a specialist in plankton, and we've been collecting plankton and jellyfish for him. And what I guess part on this expedition, because we've got so many different scientists involved, it's this what's the word, try to accommodate everybody's objectives, and so I think that we've been doing that really well. The dives are a specific time and a specific depth, and we've got all these objectives that we need to meet for different people, so we're kind of accommodating each other and making sure that we allow time for collecting of biological samples and geological samples, and some that differs on every dive depending on the dive site and the length of the dive. So it's constant communication, constant checking in and back and forth with each other and dipping in and dipping out. So as well as what you see on the commentary on the live stream, we've also got our computers set up. We're talking to each other remotely on a different chat that you guys out there don't see, and getting lots of input from the other scientists onshore as well. So it's busy. Communication is the key.
Yeah, that's right. And this is really quite different to your traditional expedition at sea, where you go out with a core group of people, you come back with the same number of people, but there's really very little interaction with ashore. Now, this is completely different. I think the expeditions of the future is you've got some people physically on board the ship, but then you are remotely connected to lots and lots of people, and they're actually watching in near real time. And so, we might be we might be sitting in a control room and the ROV is skimming across the seafloor, and then we'll quickly hear on, say, a Slack channel, someone will say, "Oh, I'd like that soft coral," and we get that instantaneously, and then we can talk to the ROV pilots, and they can drive down, collect that soft coral for somebody who's on the other side of the country or even the other side of the world. And so, our science team is just far, far bigger than anything that's physically on board the ship. It's huge, and it's really quite exciting to be part of all this.
I'd also add that the data that is collected on Falkor is also publicly available, so that it's not just the scientists watching or the scientists that are on board, but anybody anywhere can really use the data that's being collected. I'd like to take a stop here. We have several questions coming in from our viewers, and I want to make sure we answer a few of them. J. Clay 6 is a year 5 student and wants to know if either one of you have ever found an underwater volcano.
I haven't, but Rob's nodding, but I have been on surveys where we've mapped across very deep remote seamounts, which are probably old extinct underwater volcanoes, but Rob's nodding, so I'll let him describe his experience.
Yes, I've been mapping the seafloor for a very long time, and mainly in this part of the world, the Great Barrier Reef and the Coral Sea. But last year, I was on expedition with Australia's Marine National Facility, which is called RV Investigator, and it's Australia's largest blue water research ship. And I joined an expedition with Joanne Whitaker and a group of colleagues from the University of Sydney, and we went out into the very far eastern side of Australia's Coral Sea, and there's a line of extinct volcanoes called the Tasmantid Seamounts, and they're very dramatic looking. They look like a series of, they do look volcano-like, and they're a line. So this is part of this hotspot volcano that runs up the eastern side of Australia. Now, they were extinct. So in the long distant past, they were once exploding and belching out lava and the like underwater. Now they're extinct, but they form these classic volcano shapes across the seafloor, and we were mapping them and actually dredging the old basalt rocks from them, just as you would on shore, except that they're in about 3,000 meters of water. But I have in fact actually gone over live volcanoes up in Papua New Guinea, and up there, it's a very active area. It's part of this ring of fire. So north of Australia, it lies Papua New Guinea, and the ring of fire goes all the way around the Pacific, and Papua New Guinea is part of that. So is New Zealand. So it's an area that's tectonically very active, lots of earthquakes, lots of volcanoes, and around New Britain, which is on the northeast side of Papua New Guinea, we actually surveyed over the top of an erupting volcano that was about probably 2 kilometres deep, and we could very easily see the smoke belching in the sonar systems that we were mapping it with. So it can be quite exciting. And we had a really clear signal that there was a live volcano, because the following day, great rafts of pumice washed up around the ship that we're on. So pumice it's a volcanic glass, and it floats because it's full of little holes, little gas bubbles. And this pumice washes up along beaches all along Australia, or Eastern Australia. But in the morning, after going on top of this really live volcano, it was fresh, and the rafts were about as big as this table. You could almost walk on them, but they completely surrounded the ship. Back to you, Carly.
That's amazing. You see so many great things. Another question has come in from Gunning Public School. How long do scientists stay out on the reef studying? Do one of you want to take that one?
Yeah, so currently on this survey, so we are living on board RV Falkor. So we've all got cabins. We sleep out here. We don't go back home to the mainland at the end of the day. We have all our meals on here, and we're all living together on the vessel with all of the ship's crew and the ROV pilots. I think so this particular expedition has been divided up in 2 legs, leg 1 and leg 2. And I came on leg 1 on the 2nd of August. And we get home back to, at the end of the survey, into Brisbane on the 30th of August. So that's how long I'll be out here living on RV Falkor and studying these reefs.
Yeah,
about a month. And Rob was joining us remotely from his home in Cairns during leg 1, and then he came on board on the 12th of August.
So about 2 weeks for me.
2 weeks.
Marty's one of the science crew who've stayed on board for the entire time. But, you know, I think this is quite typical. A blue water expedition like this on a large research ship is typically about a month. But, you know, maybe only once, may only do this once every year or every 2 years at the most. We're not going out on these big ships, you know, every second week. It's not that common. Hence, we need to make really, really good use of the time available, because, you know, it's expensive to run these ships, and it takes a lot of effort to get everyone in place. So we're just very fortunate that we're on the Falkor for this 1 month, and we, you know, we'll make really great use of the ROV and the mapping to explore the deep Great Barrier Reef.
Now, I'm sure most of your time is spent focused on the science, but I'm sure some of our viewers are wondering what life is like on a research vessel. So can you walk us through a typical day of what it's like on Falkor, and a little bit more about how you live, sleep, eat, and do your science aboard?
All right, it's quite a simple life, really. For most of the crew, they're in typically 12-hour watches. So they're on working for 12 hours, and then they're off watch for 12 hours. It's important not to get fatigued or tired on board, and then you start making poor decisions. But the idea is to get into a bit of a routine. And if you think of it, it's just like a little village of people. We have chefs. We have stewards to help keep our cabins clean and the like, and do a bit of tidying up. But we have the master or captain of the ship, and here we have Captain Phil. He's in overall charge of the entire ship. He has a bridge team which help drive the ship around. We have an ROV crew. We have many different kinds of technicians, and of course the engineers helping keep all the engines running. So, you know, everyone's working at different hours of the day. But as a science crew, where most of the operations are happening during daytime, when we put the ROV in the water, typically we might wake up around about 6 o'clock in the morning. The sun has come up. You're seeing some pictures now of the Great Barrier Reef. The weather here is just glorious. It is absolutely flat, beautiful conditions. But we wake up about 6 o'clock. 7 o'clock is breakfast. We can have, it's a big buffet breakfast. It's really nice. And then usually around about 7:30, we have a meeting of everybody, all the important staff on board, and we talk about the day's events. By about 8:30, the ROV is going back into the water, and we plan a full day of ROV diving all the way through the day. Typically, we pull the ROV out just before sunset, at which time everyone swarms all over the ROV because we've brought samples up, all the rocks, the marine biology that we've collected down there with the arm. Then there's, of course, there was lunch in there. We have dinner. Again, the food is just fantastic. But typically late into the night, many of the science crew are actually sampling and putting into bags all of the samples that have been collected during the day. For myself, I'm usually asleep by 8, 9 o'clock because I have had a very early start. We all try and get some rest, and then it all starts over again. So it's quite constant, but we don't want to exhaust ourselves. It's a matter of getting into a routine, and this is a lovely environment to be in, but it is quite a full working day.
Yeah, it is a long day, and we're concentrating during the ROV dive. So we're all in that control room, we're all watching the screens, and it's fun. We're having lots of fun. Like, there's nowhere else we would rather be. This is our job, this is what we love, and to be out here on Falkor is such a privilege, and to have ROV Sebastian. So we're glued to those screens all day, and that could be for 7, 8 hours, and concentrating. So even though we're just sitting there for long hours, you actually do get quite tired. And then, as Rob was saying, at the end of the day, the ROV comes up. And so there's still hours of work ahead in the labs for those that are coming in, grabbing all the biological samples and the rock samples. So quite long days and some late nights, but those routines tend to kind of revolve around the meal times, which is really nice that you don't have to think about that and worry about that. It's just all laid on for you. So yeah, long days, hard work, but a lot of fun, and nowhere else we'd rather be.
Yeah, and just to sort of talk about that 24-hour operation, long after the ROV work is finished, we have another group of people that come in, and this is the mapping team, and they're, I guess, using the sonar, the multi-beam sonar, to create these beautiful 3D maps. Now, we do need these because this helps us plan the ROV dives on the next day. So we need to have that really fine-scale, three-dimensional pictures of the seafloor generated using this multi-beam sonar. And so through the dark night hours, the ship is driving backwards and forwards, mapping with the sonar, because there's always noise and it has to be cleaned. But generally by about in the morning, as the sun's coming up, the multi-beam mapping team have completed their work. They present the new maps. We make decisions about where the ROV will go, and we plan our next day's diving. But as we're in that control room, there's a lot going on. We have a team of people who are logging all the different animals we see. So every time we see like an interesting animal, like an octopus or a shark or something like that, they'll press a button, they'll type in what it is, and it automatically tags a time and a depth and a position for that animal, so that we can go back later and pull out the imagery for that animal and give it to other, let's say, experts around the world who might know more about that animal than we do. But at least we have an image that's tagged for it. So there's this whole exercise of tagging and logging and describing and doing the audio as well, right through the ROV dive. So it's quite a big effort.
Thank you for walking us through. It sounds so exciting, your day-to-day on board. I wish I could be out there with you guys. Here's a question from Bourke Street Public School. Have you ever found any new species?
Yeah, so in general, yes, but specifically on this dive. So our black coral expert, Jeremy Horowitz, is on board, and he's had a couple of very exciting dives where he's collected some samples that he's fairly sure are new species, but he doesn't like to claim that just right away. He likes to wait till he gets back on shore, back to his museum that he works for, into the laboratory, and they do DNA analysis just to confirm if it is or isn't new species. The other thing that we do have discovered on this voyage as well is what we call a range expansion. So it might not be a new species, but it might be a species that's not previously been recorded in this region. So we've had a number of those new range expansions, and that's really exciting too.
Yeah, I agree. And, you know, just to talk about Jeremy, he really is a black coral expert, like a world leader. And what I like is when he looks at something and he goes, oh, I don't know what this is, you know, and you think, okay, he probably has found a new species, but of course it has to be DNA analyzed and put under a microscope. But generally, if he is saying, I don't know what this is, it's pretty likely it's a new species. And yesterday we were coming up this big steep wall. It's about 200-meter high cliff right in front of the Great Barrier Reef. And we came across this huge tree. It looked like a tree, but in fact it's a black coral. It's a living animal, and it creates all these big branches, big, long, thin branches. And it was, you know, it was nearly as high as the roof here, wasn't it? It looked like someone had just put a Christmas tree on top of the ROV, and they were trying to put it in. We've got these boxes about, you know, a few meters across, and we're really struggling to get it inside. That's right. So, you know, there's that, and we're going back out into the offshore Coral Sea area on the Queensland Plateau, which is right adjacent to the Great Barrier Reef, and there are all kinds of fish out there that have never been described, and we do know that we've discovered new fish species. So the Leg 1 team have been out, who were out there just a few weeks ago. They're getting vision of, I guess, fish that have never been described before in, you know, in any kind of history. But the range expansion that Marty talks about is important. So, for instance, fish that have only ever previously been found in Hawaii are suddenly found here in Australia. Now, it's not like they suddenly swam all the way here and we found them. They were always here. It's just that we've never seen them here before. And this is the beauty of this, you know, high quality imagery that we get from the ROV Sebastian is the quality is so good that we can actually do this identification, and, you know, we can say that this is either a new species of fish, or we know what fish it is, but it's the first time it's ever been seen in these waters. And so for experts around the world, this is, you know, very, very important to try and describe not only what we have, but where it is. And that only that way can we really protect it.
Excellent. And we have a couple questions that have come in asking about rubbish and plastic, and if you've seen any during your dives on this leg.
Yes, we have, unfortunately. We haven't actually seen a lot of plastic, have we? No. What we've seen have been a few bottles, glass bottles, drink cans, and a bit of fishing line around when we were out on the Cairns Seamount. So we have seen not a lot, but we have seen some. And ROV Sebastian stops for rubbish. We stop and pick up the bottles and put them into the bio box that we normally put the rocks and corals into, and we bring them up to the surface with us and put them in the bin properly. And all our rubbish gets taken home with us back on shore at the end of the survey.
So just on that, there are things that we also see on the seafloor that have been washed off land. And this is one of the, I guess, the tests, the hypotheses that we were looking at. There's a canyon that we were studying yesterday that is connected to the Great Barrier Reef shelf. That is, the head of the canyon just sits directly between two reefs, two shallow reefs. So it's open to the continental shelf itself, and lo and behold, we actually found wood and we found coconuts on the seafloor. Now, the wood was being used by all kinds of animals as a home, little habitat. So we found barnacles and there was shrimp all over it. But it was really interesting to see that there was timber or wood that had probably been washed off from shore, down rivers, across the Great Barrier Reef Lagoon, and then deposited into the deeper oceans. But, you know, it's not like that we have seen a lot of rubbish, but just yesterday we did see a few bottles. But we are picking up the litter as we go along.
That's great
Back
to
to you,
hear. Along those lines, another question that's popped up a few times here is if your team has encountered any bleached coral reef.
So when we were out on the Queensland Plateau we were on deeper reefs out there, and we didn't really see evidence of coral bleaching. When I say deeper reefs out there, I'm talking, the top of the reef was still in about 40 metres of water, and they were really pristine, healthy coral reefs. So we didn't really see evidence of bleaching out there. We've come back into the outer edge of the Great Barrier Reef, and we're not really up in the shallow part of the coral reef where you might see evidence of coral bleaching. We're out on the seaward side and on the front of the coral reef where it drops away steeply down to the deep ocean. So yeah, we've been fairly deep, so we really haven't seen evidence of coral bleaching, but we are in a location where there has been fairly extensive coral bleaching in previous years, but we're not in that shallow coral reef, so we're not seeing that directly ourselves right now.
Great. And another question, and this is actually one of my questions I'm very curious, is at what depth do you start to see bleaching at? Have you been able to establish sort of that line where the bleaching starts and stops?
Yeah, so I know a little bit about this because I live in North Queensland and I experienced that big bleaching event back in 2016. And in fact, one of our colleagues, Tom Bridge, he's not on the ship at the moment, but he heads up he's in the Museum of Tropical Queensland, and he's a deep coral specialist. So back in 2016, Tom was one of these people who are involved with the surveys of the coral, looking for how far down it was bleaching. And they did see the effects of bleaching down to around about 40 metres depth. That's about the upper limit depth that we've been going with the ROV Sebastian. And as Marty said, we've not seen any evidence at all in those what we call mesophotic zone. That's that twilight zone, just below those shallow coral reefs. So what we can say is that the corals that we've seen, the hard corals that we've seen, as shallow as we possibly can go with the Sebastian, are looking very, very healthy. Like I think about out in the Coral Sea where we're going for our next leg, and previous expedition just found extensive fields of beautiful living hard corals they're not bleached at all. So it isn't. Of course, it isn't everywhere. It is patchy, and certainly some areas of the Great Barrier Reef are suffering more than others. But because it is such a big system, it's the biggest coral reef ecosystem on Earth, stretches at least 2,500 kilometres north-south, and in places it's 300 kilometres wide. There are parts, big areas of the Great Barrier Reef that are in quite good condition, and yet some parts are suffering. But I can tell you the deeper coral reefs that we've seen so far are just amazing to look at.
Very diverse and very abundant coral cover.
Excellent. So we're getting a ton of questions. Surprisingly, we've had 4 questions now as if a shark has ever attacked the ROV. I'm not sure if that's happened on this expedition, but we have certainly had sharks go after equipment before. Have either of you had any experiences with that?
For myself, not on this voyage per se, but I have been involved with other expeditions where we tow, let's say, what's called a continuous plankton recorder, and it's a very simple machine. You basically, it's on the end of a cable, and it's got it's almost like fly trap paper, and it's continually rolling and taking in water through a little funnel, and then it takes the plankton that it captures in there and layers it on this roll of silk, and that silk rolls up, and every 100 kilometers or so you pull it in, preserve that roll and put another roll, and off you go. And we've brought that back with big teeth marks all over it where something's had a really good chew. Marty, have you ever had an experience like that?
Yeah, I've actually, one of my field surveys to the Northern Great Barrier Reef, but not quite where we are now. It was sort of landward of where we're sitting. I was doing some field work, and I took with me a very small ROV, very small compared to Sebastian. It's just a 10 kilo, it's called a Blue Rov 2. And I was flying that down to about 25 meters on a reef pinnacle, and it's got little thrusters that vibrate. And I think that might be what attracted the shark. So I had a shark come out of the distance beyond my range of visibility, so you couldn't see. And then it came straight, like front on into the camera of the ROV, almost bumped it with its nose, and then off it flew away again. So when I play that video back, when I play that video footage to my friends and family, it looks like I was scuba diving and that it was me that was filming that, and the shark came right up to me. So I didn't tell anybody that it was an ROV that took that video, that it wasn't actually me. But yeah, that was a lot of fun.
Well, while we're on the topic of animals, we've also had several questions about your favorite animal or coral, or if there's been something really incredible that you've seen, or the types of animals you've seen on the current cruise.
Well, I guess I have two favorite animals. I've really enjoyed the cephalopods, right? Cephalopods include the octopus, the nautilus, squid, and cuttlefish. Today we saw two deep water octopus. One was a Dumbo octopus, so it has these funny flapping ears, and everyone agrees that the ship stops for Dumbo octopus. It doesn't matter what we're doing, what transect we're doing, or what kind of, rigid scientific observation we do, we stop for Dumbo octopus, right? So we do that. The other thing we like stopping for are nautilus, and these are really strange, ancient-looking animal. We have seen one here off the Great Barrier Reef, quite a baby actually, a really small nautilus, and I really like seeing them. And we will see more of these out in the Coral Sea. I guess that's one end of the scale. The other end for me is these giant isopods. They're a crustacean. They look like a pill bug, but they're as big as almost as long as my arm, and they create these burrows in the soft sediment. And yesterday we saw a couple of living ones, and they are very, very ancient looking animal. We find them in the ancient fossil record, and they crawl around and dig on the seafloor, but they're a real almost nightmarish looking animal. Marty, what's your favorite ones?
For me, my favourite animals have been when we've been doing the plankton surveys on our descent on the dive. Some of those jellies that we've been filming, and we see them coming towards us in the water, and we're like, what's that? And these amazing jellies that they're transparent, but sometimes they've got little glowing lights on them and all their tentacles hanging down. And this is not something that is anyway remotely related to my field of work, my research. So for me, this is a new experience. It's not just plankton. When you really zoom in on those little critters, there's so much detail there, and they're vibrant and actually quite colourful, and the way that they are suspended in the water and they just float there, and we can pause and film them. And again, seeing the skill of the ROV pilots, because we need to take samples of these because they're going to have DNA analysis and go to museums. So seeing the skill of the pilots, that they use their suction sampler to suck up these jellies and it gets sucked into a jar on the ROV. So I think that's been my favourite animal highlight, has been the jellies.
Yeah, just on the jellies, we're we're lucky to have Dougal Lindsay from Jamstec join us, and he's a world expert on plankton. And unfortunately can't be on board because of the COVID issue, but he can join us remotely in from Japan, and that has been quite a revelation. I mean, we all see jellies, we see them in the water or washing up on beaches, and generally they're big, flat, flabby things of jelly. And if you pick them up in your hand, they don't have any form. They've lost all of their structure and mass. But to see them in their proper living environment, drifting and pulsating, and we can zoom around and look at what they've eaten for breakfast that day.
Yeah,
we can see because they're completely clear, they're transparent. That has been really interesting, hasn't it?
And the excitement of so Dougal's been watching remotely from onshore, but we can he's been commentating those dives too, and his excitement at seeing some of these new jellies that have so the excitement is contagious. So we're excited because he's so excited.
Back to you, Carly.
Excellent. Thank you so much. And I think while we're talking a little bit about species, it's important to note that when we're collecting species with Sebastian, it's a very delicate process, and that we only take what is needed to collect those samples, to get the DNA to really understand what species are there. And that brings us to some of our questions here. We've had quite a few people ask how you name a species once you find something new.
Yeah, I just usually name it after my girlfriend or something like that. No, just joking. Now there's all kinds of rules about how you name things, and one of the rules is you shouldn't actually name them after living people, but of course people do. But they're always usually got Latin names, and one of the things that one of the key things with naming animals is you typically want to try and give it a Latin name that is specific about a feature of that animal. So I'll give you an example. A six-barred angelfish, Pomacanthus sextriatus. Pomacanthus is the genus, that's the group of angelfish. The sextriatus is the Latin for six stripes, right? And so there's an example of how you might name a species. So even if I had never seen that particular kind of angelfish before, but I was familiar with that way of naming species, already I would know that it's a type of fish that's an angelfish, and it probably has six stripes on it somewhere. And so people who do this intelligently typically name species of animals with that characteristic. There is the other side where people who are real experts, who've put years and years of effort into studying an animal, sometimes have animals named in their honor, and that's fine too. But so there are actually rules around naming species, so it's not some flippant thing.
Great. And here's a question. I don't want to ignore the geological side of this expedition. We have lots of questions about animals, but someone has asked, what's your favorite rock, or if you've seen a really interesting rock on the expedition?
Okay, my favorite rock is one that we collected a few days ago, and I think it was from about 589 meters deep, water depth. And it's a rock that is an ancient version of what I am studying for my PhD, that I study, that is living and currently producing brand new sediment in the Great Barrier Reef. And that's from a calcareous macroalgae called Halimeda, and it's living today. It's growing, and it's a green algae, and it's got a limestone skeleton inside of it. So it's an algae that's got a skeleton, and it grows and dies, and that skeleton becomes the sediment, and that's what I'm studying. And so this rock from way down in the deep ocean would be very, very old. It would be hundreds of thousands of years old, I would say. And it's now a rock. It's been lithified. It's a solid rock. And when I split it open and looked at it, it was made up of all those limestone cornflakes, 100%. So for me, that was my favorite rock. What's yours?
Yeah, I've really enjoyed seeing these really deep rocks that we're finding at the bottom of the canyons. It's called a mudstone. We're guessing it's probably around 40 to 50 million years old, so really old rock. But in fact, it's just a piece of the Australian continent that's jutting out underneath the Great Barrier Reef. So the Great Barrier Reef is, of course, growing on this continental shelf, and we're quite curious as to what this continental shelf is made up of. But to actually see that rock exposed on the seafloor down around 1,000 meters down, over a kilometer down on the seafloor, just poking out in one of the deepest parts of these really steep valley sided canyons, for me is a revelation. We're actually seeing a piece of ancient Australia, and this is what the Great Barrier Reef has grown upon. So we've actually been mapping this area for a long time, and we have a good sense of the three-dimensional shape of the seafloor. But again, I keep coming back to the value of the ROV. We're actually ground truthing what we are mapping in 3D. Putting a camera on the seafloor to see the rock, or to see the animal, or to see the sediment, or what's feeding on the sediment has been a complete revelation. It's really opening our eyes up to, I guess, the long history of Australia and, the Great Barrier Reef, which, we have to protect. And so it's my favorite rock is that old piece of Australia.
That comes back to what we were saying earlier about hypothesis testing. We had an idea that these rocks underneath the Great Barrier Reef might have been continental. And so that was a hypothesis that we wanted to test. And now we've got a rock to give us some evidence towards that.
That's right. And it's a rock that we can put under a microscope, and we can do age dating on it to exactly pin down how old it is, and all the different, we can really study all the internal grains. So we can, really get to understand what that rock was made of and how it got there. Back to you, Carly.
I'm going to spring a little quick game on you, both of you. So we only have a few minutes left, and I want to make sure I get all of our questions answered from our incredible viewers today. So I'm going to do a rapid fire Q&A where I'm going to give each of you a few questions, and you have 2 sentences to answer the question in. Does that sound good? Are you game for that? All right. Yeah. All right, so Rob, let's start with you. How many places have you studied before?
Oh, in the Great Barrier Reef, many, many places around the world, all around the world. Been to Antarctica, South Pacific, Indian Ocean, Africa, the Far Eastern Pacific, and Northern Indian Ocean.
Well done. And Marty, have you seen any injured animals? And if so, what do you do?
Okay, thinking rapidly, we saw a couple of fish yesterday that followed us for ages and ages and ages. One of them looked as though it had a scar on its side, and it might have been a bite mark from a cookie cutter shark. And what do? Well, we don't do anything, because that's just part of the system, that's part of the ecology, that's part of nature. And so we've just observed that, and we just don't interfere or intervene, and we just let that fish be on its way.
Great. And I'm going to do a second question to you, Marty. Have you done an investigation in bad weather, like giant waves?
We have been so lucky with the weather on this trip so far, touch wood. It has been so calm. We would not have been able to sit where we are sitting right now up against the edge of the Great Barrier Reef if it was rough. When we left Cairns at the start of leg 1, the first night out was pretty rough. There were a few people that didn't really feel like having breakfast the next morning. I was one of those. But since then, we've had calm seas. We've been very lucky. I've been in rough weather elsewhere on other voyages, but not here.
Yes, I'm a marine scientist, but I get seasick quite easily.
Well, Rob, that takes us to our next question. In 2 sentences or less, how do you not get seasick?
Lie under a tree.
Yeah, unfortunately, getting seasick's part and parcel of the job. Can't be avoided.
Yeah. Rob, how can you...
Obviously, there's no trees out here.
Rob, how can you find so much? So I think Heidi Smith here is really impressed with how many things we've found so far on the expedition.
Yeah, it's amazing. That vision, even if you're in an area that's pretty flat and muddy and you think that there's nothing happening, turn your back for 5 seconds and something really crazy will pop into view. It's utterly addictive. And, you know, I'm just looking at a Coroteuthis squid. You know, I think that was our first dive that I ever saw with the Sebastian. It's mind-blowing. It's just, you know, it's really mind-blowing.
And a couple yes and no questions. Have you seen any groupers yet?
We haven't seen any really big gropers, but we have seen cod, cod, but not big groper cod. Yesterday we saw some gropers as we got closer to the shallower parts of the Great Barrier Reef where the coral was really starting to pop out, and we saw some coral trout. They're part of the cod group of animals on the Great Barrier Reef.
How about box jellyfish?
We haven't seen shallow box jellyfish. They do not come this far out. They tend to be concentrated close to the coast, but we have seen lots of medusae. This is the plankton story that Marty was talking about. Lots and lots of jellyfish, including these deep water jellies. They have this crimson purple color. They're very, very obvious. And we were watching them down at about 1 kilometer deep today. Lots and lots of them. We slurped one of them up in a vacuum pump. So we got all different ways of capturing animals, either with a grab or a net or a little slurp vacuum gun, sucker thing. So, there's lots of ways to capture animals, and there's the jellies. We've been capturing jellies for Dougal Lindsay.
Yes or no question.
Sorry, yes. No, we haven't seen box jellies. Yes, we have seen lots of deep water jellies.
Well, both of your enthusiasm and passion and really expertise has just been amazing. And I encourage everybody watching today to continue watching with us on our live dives. We've been diving every day and broadcasting it on our @SchmidtOcean YouTube and Facebook channels. Rob and Marty, are there any final words you want to say before we wrap up today?
Yes, I'd like to say hello and happy birthday to my son on shore in Brisbane. Hi, Sean. Happy birthday.
And to my family, my wife Diane, son Ben and Naomi, who are in Cairns and have been watching it on YouTube. I'll be home in a couple of weeks' time.
Excellent. Well, keep up the amazing work, and please make sure to continue following us on our adventures. We have highlight videos, we have blogs, lots of educational content out there. And please join us later this week on Friday if you want to learn more about ROV Sebastian and some of the robotics that we have been doing aboard. Peter, I'll turn it over to you to take us home.
Thanks so much, Carly, and thanks to both of you on board. What incredible vision and stories you've shared with us today. Really wonderful. I have to say that between the erupting volcanoes and the sharks you're surrounded by, I'm glad you're safe and dry aboard the vessel rather than in the water. Look, thanks to all the students who have joined us today. I hope you've enjoyed this as much as I have. Just a couple of other thank yous. So clearly Marty and Rob aboard the Falkor, to Carly and Schmidt Ocean Institute, also to Dart Connections and the Sydney Science Trail. Yeah, what a great opportunity for us to see all of this today. So thank you so much. As Carly mentioned, we have another underwater robotics stream on Friday, so please join us for that. And thank you and goodbye.